All right, dual credit, this is your acid base intro. I'm going to go over some things that you are expected to know and have practice, and this is just a helpful video to you. So sometimes I give you a stack of cards and I ask you to sort the cards into a logical order, and the whole premise is trying to get you to think about your ranking of your acids and bases, that you know that there are 6 acids that are the strongest, there are certain bases that are the strongest, and then knowing how to rank those from there on out. So some of this you were expected to kind of know from before. This is a great chart to be familiar with because you are expected to know which ones are stronger than others and recognize those just by the prompt when they're mentioned. We also generally do a micro lab, and I have you do a weak acid versus a weak base, a weak acid versus a strong base, a strong acid versus a weak base, and a strong acid versus a strong base. And the point of that is to make you recall how to do a titration, and also to recall what the difference is when we talk about a weak versus a strong. What does that look like when I'm running the pH probe on it? And what should I expect when I'm running each one of those? Each one of those have a general graph that we're looking for that we should be able to recognize. All right, a few things to go back over. I've showed you this chart before when you were in chemistry. It's a great chart to make you think about what's actually going on in that solution since we can't see them. And it always goes back to H plus and OH minus. And when I'm at the neutral point, when I'm on the neutral zone, I have the exact amount of H plus to OH. That's what it means to be neutral. When I go from the neutral side and I get more of the H plus, that's when I start becoming more acidic. And even though I'm over here, we still like to say that we still have some OH present in there. And just like over here, here's my strong basic. I still got a little bit of H plus up there. Okay. I also like this chart because it lays out, it reminds you like a 4 is a 10 to negative 4 H plus, but for an OH it's 10 to negative 10th, or a POH of a 10. So remind you how that works together with the pH scale. And to remind you about this chart that we've used before. This was how you get from pH to maybe OH. It showed you the pathways of how you get there. You follow your arrows, and it shows a relationship of those equations. Okay, so simple, but you definitely want to come back to this chart because this chart has all those types of calculations that you need to know how to do, which is what rolls into the first set of practice problems, which I don't spend much time on because you're supposed to remember how to do this. So I'm going to flip through these next slides real quick, talk about a few things, and again, this is old knowledge that you should have ready to go. So these are pH and POH calculations. Determine the pH of 0.0034 molar nitric acid. Here's my formula, and I should get down to 2.5. And then it asks for the POH. Since I know my relationship between the pH and the POH, and I've already solved for pH in the previous problem, I just need to subtract that number from the 14, and it gives me my POH. Here I'm given NaOH. This one's a nice little problem because if you follow along, you do your pH, you get 3.37, and hopefully at this point you go, I have sodium hydroxide, I cannot have a pH of a 3.37. So you take 14 minus that and you get your actual pH, which is 10.6. This problem is interesting. So I have been given 2 different moles of a strong acid, strong base. So there's my equation, and I basically just set up underneath it what my values were. So I had to figure out which one is in excess. And so I'm going to subtract the 2 numbers, and I get that I'm excess with sodium hydroxide, which means that my pH has to be on the basic side. So again, like we've done before, we plug it in. We note that we get 3.65. That can't be correct because it's sodium hydroxide. So then I'm going to do 14 minus that number, and I'm going to get my basic pH, which is 10.4. this slide is another explanation of that same idea in case you need some more. This one here, this trips people up because you see the number and you automatically want to go, I'm going to plug and chug, I got this. And I need you to take a step back and go, wait a minute, that says negative 11th. And so when I went here and I went ahead and just wrote this out to you, so you can see how really, really small that number is. So now we got to recall that this relationship between H plus and OH equals our KW value, or our ionization of water, which is 1e negative 14. And so when I look at that, my H plus is a 1.0 e to negative 7. Well, if I put those two numbers together, hopefully you can see that that 45 on the end doesn't really impact the number at all. And so when I do my pH here, I'm going to get basically a 7. Again, there's some more explanation there for you. This one here, I'm just trying to get you to think about what does that mean to be a pH of a 7, and try to get you to think about that one chart that I showed you where you got the H plus and the OH and they're equal to each other. Okay? Great job.